Hey guys, today we are looking at 2.3, which is going to talk about some applications of our trig functions that we've been learning about. So first thing, before we start looking at these applications, is we need to talk about how to plug our trig functions into our calculator. Because when we talk about applications of our trig functions, remember a lot of applications are not going to have nice, pretty whole number answers. So remember, when you are plugging things into your calculator, you need to make sure that you are in the correct mode. So that's what our caution box is over here. It says, remember that the calculator must be set in degree mode. So I've got my Calculate 84 app here. It's going to look a little bit different than your TI 84 calculator that you guys get in class, but it's pretty much the same thing. I'm going to go to mode and I'm going to come down here and make sure that I am over in degree mode instead of radian mode. Because if you look, all of ours have degree signs on them. So degree mode. And then we're just going to talk about how to plug them in. So if I'm starting with sine of 49 degrees in 12 minutes, I'm going to hit the sine button. And I'm going to type 49. And remember, we're going to hit second apps to get to our angle menu to get that degree sign. And 12, and then second apps into the angle menu to get the minute sign. Close my parentheses and type it in. Our directions say approximate the value of each expression and round to the nearest thousandth. That thousandth is the third decimal place. So when I type this in, the sine of 49 degrees and 12, oh, I put in 2 degree sign. Let's try that again. Instead of a degree sign right here, let's try the actual minutes sign. There we go. 49 degrees and 12 minutes should give you approximately 0.757. Go around to 0.757. And make sure you type it in correctly. Do better than I did. Now, we talked about secant, cosecant, and cotangent, but you will notice that you do not have buttons for that on your calculator. So that's where it's really important that you remember your reciprocal identities. If I am looking at secant, secant is the reciprocal for cosine. So I'm going to write it as the reciprocal 1 over the cosine of that 97.977 degrees. And then that is what I can plug into my calculator because I have a cosine button. I've got a sine, cosine, and tangent button, so I've got to make sure I'm in terms of sine, cosine, and tangent when I plug it in. So I'm going to do alpha x to get the fraction, and then 1 over the cosine of 97.977. And if you're not in degrees, minutes, seconds, you don't technically need to actually type in the degree sign, so I can just go ahead and close that because we're already in degree mode. It knows that you're talking about 97.977 degrees. Hit enter, and you'll notice that we get negative 7.206 is what it's going to round to. Okay, the next one we have cotangent, and it's actually 1 over cotangent, so it's already in the reciprocal form. We don't have a cotangent button, so we're going to flip it to a tangent so that we can plug it into our calculator. So it's going to be the tangent of 51.4283 degrees. And when I plug that in, the tangent of 51.4283, that is going to round to about 1.254. Make sure you are rounding correctly. Then remember we can have negative angles and you can just type it in as that negative angle. So if I've got the sine of negative 246 degrees, I can just type it in like that. The sine of negative 246 degrees. When I type that in, I get approximately 0.914. So typing it into your calculator. Now, the other way is that we may already have the function value and we need to work backwards and find what the angle is. So if you look at your buttons on your calculator, the sine, cosine, and tangent, if you look above them in blue, you'll see sine with a little -1, cosine with a little -1, and tangent with a little -1. Those are our inverse trig, and that's how we undo the sine, cosine, and tangent. Excuse me. So if I am looking at sine of theta equaling, or is approximately this decimal right here, to work backwards and try and figure out what theta is, I'm going to do the inverse sine of both sides. And that's going to cancel out here and just leave me with theta. And theta is going to be approximately the inverse sine of 0.96770915. And then that's what I can type into my calculator. So instead of just hitting sine, now I'm going to hit second sine and then type in that decimal, 0.96770915. Okay, that spits out a decimal. Our directions say round to the nearest thousandth. So once again, rounding to 3 decimal places. So theta is approximately 75 point. And notice, sorry, excuse me, we've got 3,99999, so that's actually going to round up to 75.4 degrees. Now, when you're looking at one that is one of our reciprocals that doesn't have a button on the calculator, that's where it's going to get a little bit trickier. So let's kind of come over on the side and let's do a little bit of a groundwork to kind of figure out what we're doing. Right now we have the secant of theta is approximately this decimal. I'm going to come over here and I'm going to rewrite it and say, let's say that the secant of theta does equal, and let's just say that that decimal is x for right now because I don't want to have to write that decimal over and over and over again. Okay, I don't have a secant button on my calculator, so I'm going to rewrite it as the cosine reciprocal. So instead of secant, it's going to be 1 over the cosine of theta is equal to x. But remember, we already know that x is that super long decimal. I need to go backwards and figure out what theta is. But if it's in the bottom of my fraction, I can't really do it how it is. So what I'm going to do to help myself out is I'm going to multiply both sides by cosine of theta to get it out of the denominator. So now I have 1 is equal to x times the cosine of theta. Okay, we're getting a little bit closer, but I still need that cosine by itself to be able to do my inverse of both sides. So from here, I'm going to divide both sides by x. So dividing by that super long decimal, I just don't want to write over and over again. So 1 over x is equal to the cosine of theta. And now I can take my inverse cosine of both sides. And it's going to cancel out over here. So theta is going to equal the inverse cosine of 1 over x, which remember we said that was our super long decimal. So let's come back over to our problem over here. And that's how I'm going to plug it into my calculator. To figure out what theta is, it's going to be the inverse cosine of 1 over that decimal. So it's the same idea as what we did above, where we need to do our reciprocal to get something that we can plug into our calculator, but instead of just 1 over whatever we need, the fraction part is actually inside of the inverse cosine instead of it being 1 over and then the trig function. So inverse cosine, then my fraction, 1 over the 1.054589, and we get that theta is approximately 18.515 degrees. There we go. Okay, so that's just kind of how to plug it all into the calculator. Let's actually do some examples to talk about why we need to know this. So applications means word problems. Let's talk about these word problems. I'm going to go ahead and remove my calculator so we can see the notes a little bit better. It says, when a light ray travels from one medium, such as air, to another medium, such as glass or water, the speed of the light, I'm so sorry. I'm not feeling super great, so I'm trying to get this video done in case I'm not at school the next couple days. The speed of the light and the direction in which the ray is traveling changes. These changes are given by Snell's law, which is this equation right here. C1 over C2 is equal to sine of theta 1 over sine of theta 2, where C1 is the speed of light in the first medium, C2 is the speed of light in the second medium, and theta 1 and theta 2 are the angles shown in the figure. Assume that C1 is 3 times 10 to the 8th, so it gives us one of our values, meters per second. Find the speed of light in the second medium, 4, and then it tells us theta 1 is 49 degrees, and theta 2 is 33 degrees. So what we're trying to find here is the speed of light in the second medium, which would be our C2 value. So I'm just going to plug everything in that I know and then try and solve for the part that I'm missing. So if C1 is 3 times 10 to the 8th, that's going to be the top of my first fraction. So over here, I'm going to have that 3 times 10 to the 8th. The C2 is what I'm trying to find, so I'm going to put that down in the bottom right there. Okay, then it equals theta 1 is 49 degrees, so the top over there is going to be sine of 49 degrees. And theta 2 is 33 degrees, so the bottom is going to be sine of 33 degrees. So I just need to solve this equation for C2. Whenever I have a fraction equals a fraction, the first thing that I think about is cross multiplying. So top times bottom, that's not the highlighter, top times bottom with the other side and top times bottom with the other side. So let's go ahead and cross multiply and see if that helps us out here. So that's going to get me 3 times 10 to the 8th times the sine of 33 degrees is equal to my C2 times my sine of 49 degrees. And then from here, we can see that all we need to do to get that C2 by itself is divide by that sine of 49 degrees. So C2 is going to equal my 3 times 10 to the 8th times my sine of 33 degrees divided by my sine of 49 degrees. And that's what I can plug into my calculator. Once again, make sure you are in degree mode and then just plug it in. So 3 times 10 to the 8th is the sine of 33 over the sine of 49. And my calculator spits out that C2 is equal to 216496139.4. Okay, it does tell me that I need to write my answer in scientific notation. So I'm going to pay attention to how they gave me my C1. They just had 3 times 10 to the 8th. So I'm going to follow that pattern for when I write my C2 answer. So I'm going to take this decimal and I'm going to move it over 1, 2, 3, 4, 5, 6, 7, 8 times. So C2 is going to be 2 times 10 to the 8th. They didn't have any decimals with theirs. It was just 3. So I'm going to kind of keep it the same way. If you're talking about in my math lab, they'll probably give you a little bit more specifics. And whenever I give you a test, I'll give you a little bit more specifics. But generally, you try to match your answers with how the information in the question was given to you. So there's our answer. And we've got some more examples on the back, so let's look at those. Example 4 says, when an automobile travels uphill or downhill on a highway, it experiences a force due to gravity. This force, F in pounds, is the grade resistance and is modeled by the equation F is equal to W sine of theta, where theta is the grade, so the angle, W is the weight of the automobile, and then F is the force. If the automobile is moving uphill, then theta is greater than 0, and if it's moving downhill, then theta is less than 0. And we've got 3 parts right here. So the first one says calculate F to the nearest 10 pounds for a 2,500 pound car traveling an uphill grade with theta equal to 2.5. So I'm just going to plug what I know into my equation. It says that the car is 2,500 pounds. That is the weight. So I'm going to plug that in for W. And then it tells me what theta is. So 2,500 times the sine of 2.5 degrees. Okay, when I plug all of that in, my calculator spits out 109.048464. It tells me to round my answer to the nearest 10 pounds. So 109 would round up to 110 pounds. Okay, the next one says calculate W to the nearest 100 pounds for a car traveling on a 1.5 uphill grade. So that 1.5 is going to be my theta with a grade resistance of 111 pounds. That's the force, the grade resistance. So this time my equation is going to look a little bit different. I'm going to have that 111 is going to go for the F, going to equal W times the sine of 1.5 degrees. So I got to do a little bit more work here to figure out what W is. I'm going to divide both sides by that sine of 1.5 degrees. Over here it cancels. So W is going to equal 111 divided by the sine of 1.5 degrees. When I plug that into my calculator, my calculator spits out 4,240.372052. This time it tells me to round to the nearest 100 pounds. So 4,240 is going to round down to 4,200 pounds. And the first one we solved for F, this one we solved for W. Any guesses what we're going to solve for in the last part? It says calculate theta to the nearest hundredth of a degree for a 300-pound truck. So that's our W with a grade resistance of negative 200 pounds. So that's our F, the force. So negative 200 is going to equal that 3,000 times the sine of theta. And I've got to work backwards to figure out what theta is. So I'm going to start by dividing both sides by 3,000. When I do that, I get that the sine of theta is equal to negative 200 over 3,000. And this is where I'm going to use that inverse sign that we kind of talked about on the first page. Okay, it's going to cancel out here. And I'm going to get that theta is equal to the inverse sine of negative 200 over 3,000. I can plug that into my calculator to figure out what theta is. So second sine to get the inverse sine, negative 200 divided by 3,000, and I get negative 3.8226. It tells me to round to the nearest hundredth of a degree. So that's 2 decimal places. So I would say that theta is equal to negative 3.82 degrees. And we've got one more example. This one doesn't give us an equation though, so let's talk about how we can write an equation. Any offset between a stationary radar gun and a moving target creates a cosine effect that reduces the radar reading by the cosine of the angle between the gun and the vehicle. That is, and this is the important part, the radar speed reading is the product of the actual speed and the cosine of the angle. Find the radar readings to the nearest hundredth for auto A and auto B shown in the figure, round to the nearest hundredth. So that part that I just highlighted is how we're going to get to our equation. It says the radar speed reading, so we can call that R for radar. Then it says is, so equals, and then product means that we are multiplying. So it's going to say the product of the actual speed. So I'm going to say S for speed, and then the cosine of the angle, so cosine of theta. And that's kind of how we get our equation there. And then now that I have my equation, I just need to use it for both of the cars that I have in my picture. So I'm going to draw a little line to kind of split. And let's start with auto A that's over here in blue. So my radar reading R is going to equal the actual speed, which they have as 70 miles per hour, times the cosine of my angle, which they have as 10 degrees. All I have to do from there is plug it into the calculator. So 70 cosine of 10 gives me that my radar reading would be 68 point, and it says round to the nearest hundredth, so 94 miles per hour. Okay, when I look at auto B, the radar is going to be the actual speed, which they also have as 70 miles per hour, times the cosine of the angle, but this time the angle is 19 degrees. So when I plug in 70 cosine of 19 degrees, I get that the radar reads as 66.19 miles per hour. And there we go. So I guess if you are getting read by a cop car with a radar gun, you want to be closer rather than further away. All right, that's all I have for these notes. Make sure you get started on your assignment that goes with this. Let me know if you have any questions, and y'all have a good day.